In this lecture, we will learn about the interpreter design pattern and how to implement it in Python. The interpreter design pattern is a behavioral design pattern that is used to evaluate language, grammar, or expressions. It defines the grammar of a language in an object-oriented way. Interpreter handles translating languages that we don't want to manually translate on each occasion. When do we use the interpreter pattern? We use this when we want to create our own compiler, when we create a project that has functionalities that need to be interpreted into a language that the user understands, and when some tasks in the project are written in the interpreted language and there exists a grammar to it. Let's look at the pros and cons of using the interpreter design pattern. The advantage of using the interpreter design pattern is that modifying the grammar is relatively straightforward. We just need to create a class that represents the new productions. The disadvantages of using this pattern are that it doesn't describe how to create the graph of objects for the interpreter, and it doesn't work well if the grammar has more than a few productions. Let's learn how to implement the interpreter design pattern in Python. First, we will create a variable named 1 set equal to the Roman numeral 1 as a string. Then we will create a variable named 2 set equal to the Roman numeral value of 2. We will then do this for the numbers 3, 4, and 5. Then we will do so for the numbers 9, 10, 20, 30, 40, 50, and 90. Then we will create a class named Roman numerals. Inside of this class, we will have a variable named input, initialized to an empty string, and a variable named output, initialized to an empty string. Then we will implement the init function that takes in two parameters, self and base 10 number. Inside of this function, we will set self.input equal to base 10 number. Then we will have a class named expression. Inside of this class, we will create a function named interpret that takes in two parameters, self and base 10 number. Inside of this function, we will use the pass keyword. Next, we will have a class named Roman1Expression that extends the expression. Inside of this class, we will define a function named interpret that takes in two parameters, self, and a parameter named base 10 number of type Roman numerals. Inside of this function, we will have a while loop that iterates while the base 10 number's input, -9, is greater than or equal to 0. If that is the case, we will concatenate the string 9 to the base 10 number's output value, and then we will subtract 9 from the base 10 number's input value using the minus equals operator. While the input -5 is greater than or equal to 0, we will append our constant string 5 to the output, and then subtract 5 from the input. While the input -4 is greater than or equal to 0, we will append our constant string 4 to the output, and then subtract 4 from the input. While the input -3 is greater than or equal to 0, we will append our constant string 3 to the output, and then subtract 3 from the input. While the input -2 is greater than or equal to 0, we will append our constant string 2 to the output, and then subtract 2 from the input. While the input -1 is greater than or equal to 0, we will append our constant string 1 to the output, and then subtract 1 from the input. Now we will need a class that will handle the tens digit of the base 10 number that the user inputs into the program. We will create a class named Roman10Expression that will extend the expression class. Inside of this class, we will define an interpret function that takes in a self parameter, and a parameter named value of type Roman numerals. While the input -90 is greater than or equal to 0, we will append our constant string 90 to the output, and then subtract 90 from the input. While the input -50 is greater than or equal to 0, we will append our constant string 50 to the output, and then subtract 50 from the input. While the input -40 is greater than or equal to 0, we will append our constant string 40 to the output, and then subtract 40 from the input. While the input -30 is greater than or equal to 0, we will append our constant string 30 to the output, and then subtract 30 from the input. While the input -20 is greater than or equal to 0, we will append our constant string 20 to the output, and then subtract 20 from the input. While the input -10 is greater than or equal to 0, we will append our constant string 10 to the output, and then subtract 10 from the input. Time to test our code. The first step is to create a variable named expressions, set equal to an empty list. Then we will append an object of type Roman10Expression to the expressions list. Next, we will append an object of type Roman1Expression to the expressions list. After that, we will create a variable named context, set equal to a new Roman numerals object with 56 passed in. Then we will use a for loop to iterate over each expression in expressions. Inside of the for loop, we will call expression.interpret and pass in context. Finally, we will print context.output to the console. When we run the code, you will notice that our base 10 number 56 was correctly translated into its Roman numeral version LVI. This means our code worked. In the next lecture, we will learn about the iterator design pattern and how to implement it in Python.